But in these next few problems, we're going to notice that one of your denominators needs to be factored in order to get those common denominators. It's something you're just going to have to be able to recognize. If you look at the first denominator, you have x plus 3. If you look at the second denominator, x squared minus 9, and your third denominator is x minus 3. Something you're going to have to recognize is that this second denominator can be factored. That is a difference of two squares problem. So we can actually change that denominator and we factor it to x plus 3 and x minus 3. What that does is it actually helps us see what the denominators are going to have in common. Because if you try to take those three denominators and multiply them all out, it's going to be a huge, huge problem. So we essentially just changed that denominator, we factored it, so that denominator now says x plus 3 and x minus 3. So if you look at the first denominator, it has the x plus 3, it needs the x minus 3. What you do to the bottom, you have to do to the top. So the first denominator has x plus 3 and x minus 3. Your second denominator has x plus 3 and x minus 3. If you look at your last denominator, it has the x minus 3. It needs the x plus 3. What you do to the bottom, you have to do to the top. So double check, every denominator should have x plus 3 and x minus 3. So the whole purpose in factoring that second denominator was to see what they already have in common. So now that every denominator is the same, you can cross them out just like before. So we are focusing just on the numerators. Notice that 2 did not need anything because its denominators already had everything it needed. So now we can multiply, distribute, FOIL, box method, whatever method you choose. But all we're doing now is we're solving this equation. And at any point, if you need to pause the video, you can do so. So at this point, we're solving the equation. On this side, I can combine those two like terms. So negative 15 plus 2 is negative 13. There are no like terms on this side. Now I'm going to start moving things from one side to the other, and at this point it does not matter where you start. You could have started with those x's. At this point I have to deal with my x's because I don't have any more like terms. So no matter what order you chose to solve this in, your answer should be 25. The second example we're going to look at is very similar. If you look at your denominators, you have x squared minus 1, x minus 1, and 2. If I try to take all three denominators and put them all together, it's going to end up being a mess. So hopefully you can recognize that this is a perfect square problem, difference of two squares. So this denominator, if you take the square root of 1, can be factored. So I can change this denominator to be x plus 1 and x minus 1. Now you should see something in common with some of your denominators. So this denominator I just changed to x plus 1 and x minus 1. If you look at your second denominator, it already has the x minus 1. It needs the x plus 1. What you do to the bottom, you must do to the top. If you look at your last denominator, it just has the 2. It does not have either one of those denominators, so I have to put both. So it needs the x plus 1, and it needs the x minus 1. So every denominator has x plus 1 and x minus 1. I can mark them off. So all I'm focusing on is my numerator, and notice I'm putting that minus sign in there in that numerator. So I'm going to write down what I've got, 2 minus 1, and that minus is huge because it's going to change some signs. So I'm dealing just with my numerators. Now I'm going to solve this equation. I'm going to take that negative 1 and I'm going to distribute. That's why that negative is so important, because it's going to change my signs. So negative 1x and negative 1 when I distribute. On this side, you have 1 times x and 1 times 1. That 1 is not going to change anything. So if you're k, I'm going to just mark out the 1, because 1 times anything is still just that same number. So essentially, all I have to multiply is that piece right there. You can box method that, you can FOIL it, however you choose to do that. And at this point, if you're using the box method, you may want to pause the video so that you can check your numbers. I FOILed it. You don't see the box method on your screen. But if you choose to do the box method, you're going to get the same numbers. So on this side, I have 2 like terms. 2 minus 1 is 1. And I'm going to bring down the 1x. On this side, same thing. If you have the box method, you're going to notice you have 2 like terms. Positive 1 and negative 1 are 0. So I'm going to bring down my remaining terms. At this point, I'm just trying to get everything still together, my like terms. So if I move 1 to be with the other 1, my 1's cancel. I still have x squared. Negative 1 minus 1 is negative 2. Be careful not to cancel that out. This one's a little bit more difficult because at the end, you notice you've got an x squared and an x and a constant. So at this point, I hope you recognize that we're going to have to factor it. So I'm going to move everything over to one side. Don't let this problem frustrate you, because not all of them are this long or this difficult. So on this side, I've got x squared plus 1x minus 2. I'm almost done. And again, how did I know to move everything onto one side? Because I saw an x squared, I saw an x and a constant, and I know that I'm going to have to factor that. So I'm multiplying to get negative 2. I'm adding to get 1. So that is going to be positive 2 and negative 1. Those are my factors. So when I set my factors equal to 0, and I move the 2 over, and I move the 1 over, I'm going to get negative 2 and positive 1. So in this case, my answer needed to be factored. Example 3 should be a little easier to recognize. If you look in your denominator, you have x minus 1, x minus 4, and then you have this big trinomial. In my opinion, this one is much easier to recognize that it needs to be factored before you can get your common denominators. It is a trinomial. You see x squared and x and a constant. So I know that I can use the x method. Right now, if I try to put all three denominators together like we did yesterday, it's going to be a nightmare. It's going to be huge. But if I try to factor this, you're going to see what happens. So we're multiplying to get 4, adding to get negative 5. That's going to be negative 1 and negative 4. So I just changed this denominator. I'm not canceling it yet. I'm just changing it. I'm rewriting it. So I took that denominator and I rewrote it as x minus 1 and x minus 4. What you should notice, the whole purpose in doing that, is now I see, oh, my common denominators already have something in common. So this denominator has an x minus 1 and an x minus 4. I'm going to use those two things to help me with my other denominators. In my first denominator, I have the x minus 1. I need the x minus 4. My second denominator has the x minus 4. It needs the x minus 1. Every denominator at this point should have x minus 1 and x minus 4. You always want to double check to make sure that your denominators have everything they need before you move on. So once your denominators have everything they need, I'm going to just bring everything down so I can see what numbers I'm dealing with. Notice that's a minus sign, which, as in the other example a minute ago, is going to change some things. This problem should not turn out to be quite as difficult as example 2. I am going to distribute. You can use the box method if you choose to do so. That is a negative 2 that I'm going to distribute. After I multiply, I'm going to combine my like terms and solve for x. Notice you don't see an x squared. That's a good sign because we shouldn't have to factor to get our answer. What I do notice is that I have a pair of x's that I'm going to combine, so 3 minus 2 is 1. I also have some constants. Negative 12 plus 2 is negative 10. Bring down the negative 6. I'm almost there. You add 10 to both sides. Negative 6 plus 10 is 4. That one was not nearly as messy as example 2. Again, pause the video at any time if you need to. Looking at example 4, again you're going to notice that your second denominator is a trinomial. Those are always a little bit easier for us to recognize. The whole point in us factoring the denominator first is to help us see what our common denominators are going to be. So we're multiplying to get negative 6, adding to get negative 5. It should be negative 6 and positive 1. So basically I'm taking this denominator and I'm just going to rewrite it to n minus 6 and n plus 1. Don't always assume that the other denominators are going to be your factors, because notice it's worked out perfectly both times, but it's not always going to happen that way. So if you look at your denominator, this one is n plus 1. It needs the n minus 6. The second denominator is fixed. Your third denominator has the n minus 6. It needs the n plus 1. Double check and make sure that every denominator has the n minus 6 and the n plus 1 before you move on. Now I can just deal with what I see in my numerator. You have a plus sign here, so you should not have to worry about any signs changing. So at this point, we are just solving our equation. We can distribute the 4, bring down the 1, distribute the 1, which we've discussed, anything times 1 is not going to change that number. On the left side, we're going to pick out any like terms that we already see and just combine those. Negative 24 plus 1 is negative 23. At this point, I can start moving things from side to side because I don't see any more like terms. My 23's cancel. Now I can move my n. So I'm left with 3n equals 24. And if I divide by 3 at the very end, I get 8. I'm going to stop with the video at this point, and we're not going to finish those last 2 examples. We're going to save those for tomorrow.